Artificial intelligence can revolutionize safety, sustainability, and quality in engineering and construction, yet its application often remains unclear. In his keynote address, Chris McComb will offer actionable insights on identifying AI opportunities, preparing data infrastructure for AI solutions, and understanding the trade-offs between different AI modalities in engineering. Please welcome Chris McComb.
So we know that the world is seeing dramatic shifts. They're driving huge amounts of construction activity. And all I really want you to take away from this plot is that the lines are sloping up at the end. At the same time, we know that AI is really taking off, and that's putting it lightly. By 2030, and it's 2024 right now, 2030 isn't that far away, AI is expected to contribute more than $13 trillion of annual economic activity. Huge, absolutely huge. And anytime something of that scale happens, it has an impact on construction. A lot of the work that I do personally in my research is in the domain of manufacturing, engineering design, product design. And what we're seeing there is that AI is already starting to impact the way that we create and design solutions across a variety of different problems. So these are some example parts that were actually designed and manufactured by NASA. And I think at this point, they have actually flown on missions. So we have AI-designed parts that are flying out in space. It's actually a funny story. The guy who was interviewed about these parts, the guy who designed them, said that they looked alien. And whenever you have a guy working for NASA who says the word alien, it's going to get a lot of press attention. So this is all to say that the world is changing. The way that we do engineering and design and construction is going to change at an increasing rate. So today, I'd like to speak about and share across a few different areas, including the barriers, opportunities, and trade-offs that are involved in what we like to call AI engineering. On barriers, I'll speak a little bit on some of the challenges that we've seen companies face when they start their AI journey or when they're midway along that AI journey. When it comes to opportunities, I'll speak to some of the work that I had a chance to contribute to as part of RT391 on AWP, and I see several members of the RT391 team here in the audience. And then finally, towards the end of my time today, I'll touch on some of the trade-offs that we need to consider when actually implementing some of these solutions. So when it comes to barriers, I really like to use this AI hierarchy of needs. So you might think back to your high school psychology class, undergrad psychology class, Maslow's hierarchy of needs. Does that ring any bells? Right, so it's a psychological concept. Essentially what it says is that in order to be a happy, self-actualized person, I need to have a roof over my head, I need water to drink, I need food to eat, right? And this takes the same concept but applies it to AI. If we want to achieve AI, that golden piece on the top of the hill, we need to spend a lot of effort at the base of the pyramid, right? We need to spend time putting into place data infrastructure, data logging capabilities, data cleaning capabilities to enable us to do data analytics, to do machine learning, to eventually get to the point of doing AI. And this is, all of us in this room are at different points along our journey across this pyramid, right? There are some of us who are already at the top, right? There are others of us who are, in the tiers in the middle somewhere. So in some work that my lab did, we articulated a set of sort of basic principles to help you climb this pyramid. And we refer to these as Design for Artificial Intelligence Principles, or DeFi principles. And for some of you, this might be preaching to the choir. If that's the case, I hope that this will give you some language that you can use to speak to your colleagues and speak to collaborators in order to do better machine learning and better AI. The first principle is really just digitization. It's essential to start capturing and storing every piece of data on your cyber-physical pathway just as a standard practice. Storage is relatively cheap, and honestly, you never know when you might need it. So it's worthwhile to start storing just about everything as a standard practice. As you start doing that, you have the opportunity to then start thinking about data valuation, right? So as I've saved this data, what is it going to be useful for today? What can I do with it right now? And then also, what can I do with it in 5 years, in 10 years' time, right? What are the opportunities that might be afforded at that point? So as you collect data, you need to engage in these data valuation activities. That's principle number 2. Principle number 3 is metadata quality. So if you ever see my laptop, there's a sticker right in the center that has STL with a big cross through it. I love St. Louis, but I hate the STL file type. So this is a rendering of an STL. STLs just tell you about geometry. So this is apparently some kind of ruler, but without some additional metadata about this file, I don't know the part scale. I don't know the material finish. I don't know the material I'm supposed to use. So all of this is metadata that would need to be added onto this file. So the point here is that sometimes the data that you need is the file itself. Sometimes the data that you need is attached to the file as metadata. Both are important. Next, we have machine readability. And this is, again, one of those things that might seem simple, but there's actually a good amount of effort that goes into doing this well. The idea here is that we want to make sure that every piece of data that we store can also be accessed by an AI agent or by a program without any human intervention, right? So we want to make sure that data is facile and easy to access. And this also has the side benefit of making it easy to access for people, too. Next, we have linkage integrity. In construction, we work on projects that sometimes span decades. So it's really important to be able to track assets across that time and understand what data you're capturing from each asset at every point. So if you have a shipment of Schedule 80 pipe, right, the information that you're tracking while that's in your supply chain might be very different than the information you track once that's delivered to site and installed. So linkage integrity refers to the idea of being able to connect that data at every point to the same piece of Schedule 80 pipe, right? So digital twin. And then finally, the world is changing, AI is taking off. We need to be nimble and evolve with it. So this last principle is just that, evolution, keeping up with these changes in AI. So these are some initial principles that we define to help people get through those first few barriers along the way, to get through those first layers of the pyramid. The next question is, okay, let's say we can do that. Let's say we have our data in place. We have all that we need to actually start doing AI. What can we actually accomplish? So this is where I'd like to bring in some of the work that I had the pleasure of doing with RT391. And our big question that we were trying to answer is, what are the opportunities for using AI to supercharge the AWP workflow? And we expanded that a little bit to look at AI, machine learning, and data analytics as well. And in doing so, over our 2-year project, we followed the design thinking process. And I'm going to give a very, very condensed overview right now, and I hope that I can do it justice. So over the course of these 2 years, we engaged with over 170 industry stakeholders that had all told more than a millennium of industry experience, more than 1,000 years of industry experience, and represented over 26 countries. So this was a global perspective, and we were trying to understand what are the opportunities that people see for embracing AI in AWP, and also what are the challenges that they're facing. And I want to talk about 3 of those today. So the first one that I'm going to touch on was actually a top concern for our EPCs that responded to the interviews and survey. And they saw this challenge or an opportunity for using AI to do more effective materials management. And that's come up in several of the presentations and Q&A today. And in this, we were responding to statements like, I want to flexibly and quickly source materials based on cost and schedule in order to respond to delays. So there's this idea of using AI to be more adaptive. The next case was the most important for our owner group, project progress management. And the idea here is I want detailed information so I can track progress instead of manually confirming. And this actually harkens back to our last speaker, right? I don't want to be standing on the edge 100 feet above or 1,000 feet above, right? I want a drone flying up there and looking around for me, or some other AI tool, right? So there's automation and adaptivity, again. And then this third area is generating the path of construction. And this was of huge interest for our service providers. The quote was, "I want to quickly iterate on the path of construction options instead of manually building paths," right? So again, getting away from manual building, getting towards some automation. And there's this idea that, yeah, I might need to adapt my path of construction in order to changing needs. So adaptivity and automation. So these two things came through really strong across these three areas: generating the path of construction, material management, and project progress. But when we think about how to actually start implementing some of these solution categories, that's not going to be pure AI, right? Most good AI solutions don't function in a vacuum. They work closely with human stakeholders. Good AI works with good people. And I think that's something that as we think about AI in construction, we really need to take seriously. In many cases, the implementation of the solutions that we dream of rely on AI collaborating with human workers. So I'd like to transition to talking about some of these trade-offs in how we put together this AI system, how we build it, and how we structure that set of interactions with human stakeholders. So we have this 2x2 matrix that we've started to use in the Human AI Design Initiative at CMU, which I have the pleasure of leading. And across the top, we have reactive versus proactive. So a reactive AI agent is one where you might press a button and receive a response. A proactive agent is one that might send you a message on Teams and ask you to do something instead. On the side, we have problem-focused versus process-focused. A problem-focused AI is going to try to give you solutions to a problem. A process-focused AI might be guiding you as you find solutions to the problem. I think in the keynote this morning, Bergen mentioned an AI that helps you plan out your day, right? That would be an example of a process-focused AI. So I'd like to talk through AI as a tool, AI as a partner, and AI as a coach. And I'll use the same example for all of them. We were working on this project that had to do with last mile logistics. So using drones to make deliveries and that sort of final mile to get to somebody's house from a warehouse. And we put together teams of 5 or 6 people who were tasked with building a drone design startup. So we had some people who were in a design role. So they were creating drones, they were swapping out rotors, putting airfoils on the drone, trying to figure out what worked. We had some folks who were in operations, so they were tasked with figuring out, okay, given this set of drones that have been given, how do I most effectively and efficiently route those around town to make all of the deliveries that I have to make? And then we figured out during pilot testing that we needed somebody in a business role. And I think this was probably because we were dealing with engineers. So what we ended up saying was that if you just let design and ops start doing cool stuff, the engineers in the design roles will build the biggest, most beautiful drone you've ever seen, and they will lose all of your money. So we needed somebody in that dedicated business role. And just to give you a sense for what they were doing, here's the interface that they were provided with. We had something like this for operations and also for business. So essentially a stripped down drone CAD environment. So there's this central area where they construct their drone, adding rotors to it, adding airfoils, and then doing a physics-based simulation to evaluate how fast it can fly, how far it can fly, et cetera. We had something very similar for operations and for business as well. What was great is that this allowed us to capture lots of data. But we also had an AI tool that was in this interface. So essentially that AI tool served as an easy button, looked at your current design, and then provided 5 or 6 alterations or modifications on that design that were intended to improve its range, decrease its cost, improve its payload. And because we built this from the ground up, we instrumented the heck out of it. So we could pull off every point and click that somebody did in the environment. We were able to pull off every chat message that they sent back and forth. So this was a wealth of data to reconstruct their problem-solving process after the fact. So to start off with, I want to show a comparison between people who were using AI as a tool, and teams that had no AI support. And I want to start by looking at that in terms of profit. This is the least exciting plot they'll show you today. So the AI-assisted teams generate a lot more profit than the non-AI-assisted teams. Woohoo! What's more interesting is how they did it. So once we start to dig into some of the actions that they were taking and how much communication they were doing, here we essentially just count these two activities. Roughly speaking, a participant working through this process was either doing stuff or talking to people, right? So this is sort of a breakdown of their actions. And we see that it flip-flops. So our AI-assisted teams end up talking more and doing a little bit less, while our human-only teams do more and talk less. So there's this shift in human reasoning. So we see that AI-assisted teams deliver better solutions, but they also shift their focus towards more strategic work and less tactical work, right? So there's this shift onto communication and sense-making when you use AI as a tool. So moving on to AI as a partner. So in this case, we wanted to take a look at our AI agent from our first study, but this time wrap a natural language interface around it and replace members of the team with this AI agent. So we were comparing teams of 5 humans, like this, 2 design specialists, 2 operations specialists, 1 business person, with hybrid teams, where we actually replace 2 members of the team with AI agents. And in this experiment, we were especially interested in how these teams fail. So halfway through, we injected a shock. So we said that drones could be no larger than some size, and also that there was a no-fly area around town. And these were constraints that were not given to the AI and fundamentally could not be represented in the AI architecture that we were using. So we expected at that point, halfway through, everything would fall apart. That didn't happen. So we started digging in. We ended up seeing that human and hybrid teams do about the same. So we dug in and saw this really interesting factor going on in communication. So this shows the communication for the hybrid teams. Session 1 is business as normal. Session 2 is the shock environment. And what we see is that the human to AI communication almost triples. So people in the team are talking to AI agents in the team in order to pull them sort of kicking and screaming across the finish line, right? With the idea being that they're trying to coax better performance out of their teammates. So this was before the days of ChatGPT, but we saw this as sort of an early form of prompt engineering. So the hybrid teams performed on par with human teams. They communicated to adapt and communicated to overcome. One important factor, though, is that we saw usually one person within the team take on the role of communicating with these AI agents. So we refer to this person as sort of an AI handler. And this was really interesting to see, but they also got really stressed out and really pissed off because they were constantly communicating and coaxing these AI agents. And I think there's an important lesson here. So as we think about the AI that we want to have, where does adaptivity get handled, right? Do we handle that as the people in the system, or is the AI adaptive in itself? Do we trust an AI to be adaptive, or do we want people doing that? And what's the human toll of placing that burden on somebody? So last but not least, I want to talk about AI as a coach. So this came out of some work by a colleague that showed that if you have a team of 5 people, and you can allocate them to any combination of managers and engineers, your best bet is to have 4 engineers and 1 person in a team management role. So we started asking the question, can we automate that team management or team facilitation role? So we're looking here at pretty much the same configuration for our teams. A couple of designers, a couple of operations specialists, a problem manager, but then we also put either an AI coach or a human coach on top. And just to skip to the punchline, the AI facilitated teams were on par with human facilitated teams. But what we ended up seeing was that human coaches are able to give more targeted sort of one-on-one guidance. So I think there's a really interesting thread here about an AI coach working with somebody in a management role, right? Because if an AI coach can take over 80% of what my day-to-day hassle is with the team, What does that free me up to do as a manager, right? That frees me up to be a mentor. That frees me up to help people progress in their careers, things that I'm probably pretty excited about. So to close out today, I want to address the elephant in the room, which are large language models. So you've probably played with language models at some point, be that ChatGPT, Gemini, Claude, Perplexity. There are a ton of them out there at this point. In case you haven't engaged with a chatbot or a language model, I pulled one up and asked it what it knows about CII. And this is without searching the internet, just based on what the model knows. And it does a pretty good job of describing what CII is and what CII does. So this illustrates the point that these models have a lot of really strong reasoning and generalization capability. If we start to wrap some supporting infrastructure around language models, we can get to something called an AI agent. So AI agents can do amazing things. This is an example that I love, where they put together several language model AI agents and actually had them function as a software development team and generate new software, evaluating it, proving it, testing it. In my own work, we've been looking at language models to do things like material selection. And it turns out that when you do material selection using off-the-shelf language models, they really like exotic materials. So they'll recommend titanium, carbon fiber, because that's overrepresented on the internet, right? We've also done some work looking at brainstorming assistants. And what we've seen there is that many language models tend to be less creative than people, but offer more feasible solutions. But while we're doing all of this work, the ground is shifting under our feet. So this is a plot that's supposed to show the state of the art for language models. And between the time I submitted my slides to CII and am giving this presentation, there are more that need to be added to this. So this shows, some of the common models that you might be familiar with, like GPT-4, also some that you might not be familiar with, like Phi-3. So we have these huge models that have trillions of parameters, and then we have these really fun small models, these nano models that have, only a few billion parameters, right? But what's nice about these is that they're quick and they're cheap. And they do a pretty good job, right? But these really large models are expensive, they're a little slower, but they're really expressive, right? These are the models that write poetry. These smaller models count. So there's a lot of uncertainty in the world right now. New language models coming out constantly. Like I said, the world is shifting under our feet. And whenever I come into a situation that's like this, I tend to look to the people who've been doing this job for longer than I have and see what they have to say. So the first one of those is Kate Crawford. So Kate Crawford is a principal researcher at Microsoft and has been working in AI for longer than I've been alive. And she tells us data and data sets are not objective. They are creations of human design. We give numbers their voice, draw inference from them, and define their meaning through our interpretations. So I think now, more than any other time, is the time to start investing in data infrastructure. We all have data. It's time to help surface that data and use it to tell the stories that we need to produce effective and powerful AI. The second person that I've been looking to recently is Meredith Broussard. So Meredith Broussard is a professor at NYU, and she's actually a professor in data-driven journalism. And she reminds us that no statistical prediction can or will ever be 100% accurate, because human beings are not and never will be statistics. So the recommendation that I draw from this is, this is the time to start embracing human AI teaming and human AI collaboration as a way to account for imperfection, both our imperfection as people, but also the imperfection of AI models. I think there's a lot of potential for a synergetic union. Then last but not least, Fei-Fei Li. So if you've ever heard of the ImageNet dataset, right, foundational for a lot of computer vision, Fei-Fei created that. She is widely referred to as the godmother of AI. And she reminds us that AI is everywhere. It's not that big, scary thing in the future. AI is here with us. And the recommendation that I sort of tease out of that is that now is the time to empower your people to prototype and play with AI. The best time to start playing with AI was yesterday. The second best time is right now before we head to the USS Midway. There are so many great tools that you can pull up in a browser window, pull up on your phone. The best time to play is right now. So with that, thank you very much, and I'd be happy to take any questions that you have. And while we're getting some questions, I just want to point out that this top QR code will take you to an abbreviated report from RT391. And then the bottom QR code will take you to the paper that lays out that quad chart. So thank you.
Thank you so much, Chris. I know we were talking about your ponytail earlier. It's crazy because my son's name is Christopher as well, and he has long hair. So yes, but let's start off with, can you expound on the need for AI in construction?
Yeah, so I think that's a really interesting question. And in construction, we have a long record of caring deeply about safety. And I think that when it comes to AI, the really exciting use case is to further double down on that legacy of safety in construction.
Okay. What is the difference between a language model and an AI agent?
Good question. So this is, I think Burjin started to sort of tease out some of these differences earlier. These get used synonymously a lot, but a language model is sort of the core model. Language models make mistakes, language models hallucinate, language models will tell lies, but you can use those as a component as part of a more complex AI agent and put some safeguards around it, right? So do some evaluation of the response, things like that, pre-processing, post-processing. So AI agents are sort of like the engineered version of a large language model. Thank you.
Thank you.
Yeah, great question.
Next question, how do we go about creating business cases for adopting AI?
Yeah, good point. I think when it comes to building business cases for adopting AI, largely speaking, like AI shouldn't be in the business case explicitly, right? In many cases, these should be directly need-driven. And we shouldn't be doing AI for the sake of doing AI, right? We should be doing AI because it helps us and supports us in delivering on time, on budget, with zero injuries and things like that, right? Yeah, I hope that answers the question.
This is a really good one.
Yeah.
How do we protect our intellectual property when using AI?
Yeah, great question. So protecting intellectual property is a huge concern, and I was talking to some folks from LANL, and we were talking about how we protect national security when it comes to AI. These are huge concerns. There's a big choice to be made about, do I run on-premise models, right? Do I have a computer sitting in my office somewhere that runs the model that's not connected to the internet? There are costs associated with that, right? Or do I run cloud services, right? I'm letting go of some control over my data, over the model, but lower latency, better speed, better scalability. So in many cases, that security and privacy of your data is going to be tough to maintain unless you're running something that's purely on premises.
Okay, so we have quite a few questions that are coming
awesome.
in. But the next question is, how can AI impact construction productivity and the analytics associated to construction activities?
So analytics is a huge area. And I think that's probably one of the areas where AI is increasingly ready for prime time, is in analytics. So computer vision applications are pretty great at this point. I can imagine that there are some nice video applications that can be applied on a job site to do personnel tracking, equipment tracking, things like that. So I can imagine that AI has a lot to contribute to construction analytics.
Okay, well, we have a couple votes on this question. How do we balance the need and benefits of AI with the need to protect our clients' data?
Yeah, I think that's a really good question. I would say you need to protect your client's data first and foremost. And if there's an AI application that you're using that might leak their data, I mean, that shouldn't be something you consider. So I think this is where it comes in that we increasingly need to become data literate and AI literate, right? Because we need to understand, as we're working with clients, if I'm working on a client and using this chatbot, right, am I risking that client's data as I use this tool? So we need to be proficient and well educated on the tools that we know. So to that end, I'm happy to talk to anybody about language models and AI. I love geeking out about this stuff.
Okay, and for the sake of time, this will be the last question. What are some AI use cases in engineering that are implementable today?
So I think lots of AI use cases around documentation are very implementable today. So actually, if you go to my website, and if you're on mobile and click through on Explore Publications, that will take you to a retrieval augmented generation AI chatbot. And essentially, all that bot does is when it gets your question, it says, OK, let me look up the answer to this. And it runs over to its database and finds the 5 most relevant publications and then reads those before it answers, right? And we all have huge sets of documentation, standards, et cetera. We probably have PDFs sitting on our desktops, right? Because we look those up so frequently. And I think one of the use cases that is, potentially hugely valuable is running a retrieval augmented generation pipeline over those sets of documentation to make it chattable and interactable.